V square, yeah, that's very important. V square is simply the root goes away, we get 2x plus 1. So 2x plus 1. Now, very important thing, please. That's a half, that's a 1 there. You can say half minus 1. You have a minus a half, right? You can do that, or factorize this, right? 3 times 1, 3. 3 minus 1 is a 2. So you should get 2 factors for that. Let's just say we got 3x there, x there. We need plus 3. So it's a plus 1 minus 1. That makes sense, right? And here we have 2x plus 1 to the power half divided by 2x plus 1. I actually factorized this to see if there is a common factor as 2x plus 1. We don't, so leave it. These two you can simplify and write the final answer. So that's the gradient of the given question. Just be careful how you do those square roots, please. We have a nice question, the last and final one. That's the problem there. 5x squared minus 10x plus 9, and this they want you to find dy over dx using the quotient rule, of course. Product rule also can be used, but I will explain that after this question. Numerator, please. So we have u equals to 5x squared minus 10x plus 9. V equals to x minus 1 whole square, or maybe you can expand it, x squared minus 2x plus 1, because that's a very small one. Let's find u dash, which is pretty easy. 10x minus 10, lovely. And v dash, you all know, 2x minus 2. That's all the 4 ready for us to apply and then solve the sums. We can write the rule now, u dash v minus uv dash divided by v square, please. As I said, v square, I will come in the end. I'll come to that in the end. U dash v, u dash 10x minus 10 inside the bracket. V is x minus 1 whole square. That's actually x minus 1 whole square. So let's write x minus 1 whole square minus uv dash. U is this, right? The green one. So uv dash, which is a 5x square minus 10x plus 9. uv dash is a 2x minus 2. You know, guys, if you take a 2 common there, you actually get x minus 1, right? Divided by, there is a denominator, which is v square, right? V square, x minus 1 to the power 4. So in the numerator, it looks like we can take x minus 1 common. Okay, x minus 1 common. Nothing else is common for the time being, right? So x minus 1 is common. I'll start a big bracket there. See, what do you get? I have a 10x minus 10 multiplied by, I have 1x minus 1, okay? And then minus, the x minus 1 is gone. I'm left with that multiplied by 2. So let's just multiply this by 2. We get 10x square, and then that's a minus, please. So plus 20x and then minus 18. That's what you get inside the bracket, divided by x minus 1 to the power 4. Please understand, one of them cancels. You will have a 3 there. Let's open this bracket and collect the like terms. 10x minus 10x square minus 10x minus 10x minus 20x plus 10. That's what you get when you open the brackets, please. Copy that down the same. Minus 10x square. Looks like they cancel out. Then we have plus 20x and minus 18. Divided by, we had the x minus 1 whole cube, please. See how many terms cancel out. 10x squared cancel. 20x gone. That's going to be plus 10 minus 18. So it's a minus 8 divided by x minus 1 whole cube. That's the f dash x, or that's the dy over dx of the given question, which is that. Okay, so we just call that as uv, and then just find u dash v dash and substitute here. So After that, what I want you to know now is it's important that you know about the quotient rule. But a quotient rule can be changed into a product rule and you can solve sums. So take the denominator to the numerator, then see what happens. So if I go back to one of those questions there, we had x over 2x plus 3. Let me write that here, x over 2x plus 3, right? X divided by 2x plus 3. You can write this as x multiplied by 2x plus 3 to the power minus 1, right? The 1 becomes minus 1. Now that becomes a u, that becomes a v, that's a u times a v, that's a u over v. So quotient rule, if you want, you can take this to the top and use the product rule. You still get the same answer. Okay? Sometimes questions become difficult if you change it into the product rule. So just be careful how you manage that. That's it. So we finished the chain rule, product rule and quotient rule. Now we need to solve exponential functions and sine, cos, tan, right, the trigs. So let's see how we do the exponential function there. The proof of these is not examinable, right, the e to the x. So what I have done, I have written the basic ones here. That's the function x, that's the f dash x. So if you differentiate e to the x, you should get e to the x, right? Differentiate sine x, you should get cos x, and differentiate the cos x, you should get minus sine x. The proofs I can show you but later, but we just solve sums by using these rules now. So write them at one place and keep, please, right? So we are going to do the exponential functions, natural logs and all other stuff, but these three are very, very important. Okay, let's see question number 1. That's y equals to natural log x, and we need to differentiate this. How to differentiate the natural log x? Very important. They do ask you sometimes in the exam, please. So y equals to natural log x. Let me write natural log x equals to y and see what happens. Nothing wrong, right? Make x a subject. You all know when you transfer ln, the natural log, to the other side, it should become e to the power. The y stays as y. So I got my question nicely as x equals to e to the y. And the use of that is I know the differentiation of e to the something is e to the same thing. So I differentiate x, watch very carefully, I differentiate x with respect to y. So dx over dy, please, is equals to e to the y stays as e to the y, no changes. But our question, it was y equals to natural log x. We were supposed to find the dy over dx. So flip this, see what happens. That's over 1, right? So this becomes dy over dx equals to, that becomes 1 over e to the power y, which is, please understand, e to the y is actually x. So we substitute x there, 1 over x. So we got d over dy over dx in terms of x. So differentiation of natural log x is 1 over x. Please, please, please remember that. Let's write it here. So ln x is 1 over x. So if you integrate 1 over x, you should get ln x, but we do that afterwards. This is based on differentiation only. So I got 4 basics now. I can apply them to solve few sums. So you all know now how to integrate, how to differentiate the natural log function. Now we move to trigs. As I said, we got the basic rules for sine and cos only. It's our job to find for tan, cot, sec, cosec, etc. Tan x. What happens if we write tan x as a sine x over cos x? That looks like the quotient rule to me, u over v, or product rule if you take that to the top. So I will leave it as a quotient rule. You all know tan is sine over cos. Then we can differentiate using the quotient rule. So I'm saying u equals to sine x and v equals to cos x. Now differentiation of sine x, please. So u dash sine theta is nothing but cos theta. V dash cos theta is, just be careful, that's a minus sine theta, please. So I got 4 of them ready. I can substitute into the formula, which is u dash v minus uv dash divided by v square. Don't forget that, please. So u dash is cos x times v, which is cos x. So can I write that as a cos square x, because both are cos, minus u is a sin x, v dash is a minus sin x. So that's actually minus sine square x, but there is a minus, so that becomes a plus. Guys, that minus is in u dash v, this minus is in the rules, so we multiply, done. Divide by v square, which is a cos square x. When you get that, do you agree? We know from C1 or GCSE that sine square theta plus cos square theta equals to 1, the fundamental identity. So that's 1 over cos square x. By the way, 1 over cos, you all know, is a sec square x, and that's the differentiation of tan x. So if y equals to tan x, then dy over dx, please understand, is nothing but sec square x. If it's a 2x, you get a 2x there, then we use chain rule. We do that later. So that's how you do the tan x. Now we can apply the same rules and start solve the differentiations of the other trigonometric functions as well. We have a cot, so cot theta is cos theta divided by sine theta, you know, and that's a u and a v. You solve that. Okay. Then I got the next one, so you know how to do this now. We have the next one, that's a sec x, y equals to sec x. This also we can write as a fraction, 1 over cos x. You can use the quotient rule, u and v. The 1 is also a kind of a function, don't forget that. Or some people want to take the cos x to the numerator, so it should be cos x to the power minus 1 and 1 in the front, so that one doesn't play any role. Then it's basic differentiation. We are not using any chain cosine, the product or quotient rule. So cos x to the minus 1 is minus 1, right, times cos x to the minus 2, isn't it? That's what we do. And then we differentiate cos x, which is the chain rule, right? Differentiation of cos x is going to be minus sin x, right? Done. So we have minus times minus plus, so sin x stays on top, divided by cos square x. You can move that to the denominator. Guys, listen, what we did here was something to the minus 1 is minus 1 times the same thing, minus 2. Then we differentiate the bracket using the chain rule. That's how you got that. Now, to write this in standard format, what we can do, split the cos square x. So sin x divided by cos x multiplied by 1 divided by cos x. Let's write it like that. See what happens. Sin over cos is a tan, right? Sin over cos is a tan times 1 over cos is sec. So differentiation of sec theta is, please watch there, it's called sec x tan x. Okay, when you find y dash. So that also is one of the fundamental rules that you need to remember when you solve the questions, right? So we have done tan, cot and sec. There is a cosec here. I'll leave that to you. It's going to be 1 over sin x, please. Take the sin x to the top, which is sin x to the minus 1. Now you can differentiate dy over dx is equals to bracket to the minus 1 is minus 1 bracket to the minus 2. right? Then differentiate the bracket using the chain rule, which is a cos x. So we have minus cos x divided by sine square. If you take that to the denominator and split again as minus cos x over sine x and multiplied by 1 over sine x. So in the end, you're supposed to have minus cot x times cosec x. By the way, some exam boards, you don't need to know the differentiation and integration of tan, sec and cosec. Just check with the exam board and the syllabus or your textbook, right? So that's how you do the cosec. So there are so many ways of doing. You can leave it like that and then apply the quotient rule as well. Right, we finished the trigonometric fundamentals, how to differentiate using product rule or quotient rule or maybe the chain rule. Now we are supposed to do few questions, now past exam sums and the e to the power x sums as well. So let me take you through few questions there of e to the power x style, right? There we go, that's the question number 1. Y equals to e to the power 3x. We know e to the something is e to the same thing. But if it's apart from, say, if it's something else, you got to use the chain rule, right? So let's see, e to the something is e to the same thing, right? dy over dx implies, right, equals to e to the power 3x multiplied by, differentiate the 3x please, you will get a 3. So the answer is 3e to the 3x. Very, very important. Okay, let's look at this one now. Dy over dx is equals to, okay, let's go a bit close. Dy over dx is equals to e to the power something is e to the power same thing. No change, right? But use the chain rule and differentiate that again. So it's actually a minus 5. So the answer you can leave as a minus 5 e to the minus 5x. That's the gradient function of that curve. Then we have y equals to 4 e to the 2x cube. 4 is a 4. We do nothing to 4. So we leave the 4. Dy over dx equals to 4. We said e to the something is e to the same thing. So e to the power 2x cube, right? Then multiply by the differentiation of that, which is a 6x square. So the answer should look like 4 times 6, 24 e to the power 2x cube. All right, very important ones, the chain rule that comes everywhere, please. The next one we have is like that, e to the x bracket x square plus 1. Shall we call it u and v? There are two functions, right? Or you can open the bracket and then do the question also. Let me do u equals to e to the x. So u dash will be e to the x. Then v equals to x square plus 1. Guys, listen, we are in product rule, right? That's a times sign. And v dash is actually 2x. The product rule formula, don't forget, u dash v plus uv dash. Substitution, please, and see what we get. This is u dash, which is a e to the x, v is that. So e to the x bracket x square plus 1 plus u v dash is 2x. So I can say 2x e to the power x. That's how we get the answer. Is there any way to... No, we don't have any like terms, so we can leave it like this. Right, so that's the gradient function, please, of the given question. So it's x square e to the x plus e to the x and plus that. You can, but you don't need to open the bracket. So e to the power x sums we have done few, right? Now we will do with natural log and see how to solve those questions. So I got natural log x cube, that's the first one. what we said was differentiation of natural log something is exactly 1 over the same thing, right? And then see we can apply chain rule or not. So there are two ways to do this question. So watch very carefully. I call it a box. Natural log something is 1 over the same thing. Then multiply by, because it's not x, it's x cubed, use the chain rule and differentiate that, which is a 3x square. So the answer is now x squared cancel, we got 3 over x. That's one way to do. The other way is take the 3 to the front. We know the logarithmic rules, right? So we have y equals to 3 ln x. That's how it looks like. Then if you find y dash, it should be 3 times natural log x is 1 over x. That's a time sign, please, which is 3 over x. That's how you should get that. Okay, 2 types. Now let's look at the next one. It says dy over dx equals to natural log something is 1 over the same thing if you differentiate. Multiply by, differentiate that, please, which is a 5. So it should look like 5 over 5x plus 4. Please do not cancel 5, okay? That's the gradient. Now, what about this one? Natural log x square, right? Can we say dy over dx is equals to natural log something is 1 over the same thing times, differentiate the box or this bracket, chain rule, which is at 2x. So the answer should be looking like 2x over x square minus 1. There is another way to actually remember that, but we do that later here. Just I'm trying to apply the rule that we know. Chain rule, right? So this is again natural log something. We need to do dy over dx, right? Which is going to be 1 over the same thing, which is x squared plus 7x plus 12. And then differentiate that. See what you get, which is 2x plus 7. So basically, what the textbook says, or some teachers say to you, is differentiation of natural log x is f dash x over fx. That makes sense, isn't it? Because now numerator is actually differentiation of that. Denominator is that itself. So that's f dash x over fx. Right, so we did some e to the power x sums and we have done few natural log ones. And let's do some sine, cos and tan quickly. Then we can solve some examination questions, right? First sum, y equals to sine square x dy over dx. Differentiation of something's square is 2 times the same thing. Then differentiate sine x, please. It is like sine x is inside a box and there is a square. So when you differentiate that, you get 2 times the box. Then you differentiate that particular box, which is sine, comes down to cos x. You can leave it like that, or using double angles in the exam, maybe you can show that as sine 2x if they want to. Right, so that's the first one. Cos cube, you can copy and solve them, guys, you know them, right? Dy over dx equals to something's cube is 3 times the same thing's square times differentiate cos. Don't forget. So that's a minus sign. So leave it like that. Done. Y equals to sine theta. Call that theta. Y equals to sine theta. Dy over dx is equals to, or d theta or dx, okay, is sine theta becomes actually cos theta. Watch there. But you got to differentiate theta. That was a 5x minus 1. Then times by, differentiate that using the chain rule. You get 5. So the answer, don't multiply that by 5. That's the angle. That's a number. So 5 cos theta, which is 5x minus 1, should be the answer. Right? Differentiation of sine is cos. Cos is minus sine. Be careful. Dy over dx is equals to 5 sine theta